Hey, hello, welcome to the show. Look, it is time for John Park's workshop. We're here in the workshop. It's me, it's you, it's Lars, it's everyone, it's the whole gang. I forgot to change the title. We're actually doing a little bit of that, what it says down there at the bottom there, but also other slight variation on that. Let me just that in real time. I'm just gonna use the dreaded, highly dangerous word final. Boom. There we go. Yes, we're working on just a little bit. I'm going to look at the final build and the final code and functionality on the Knobby sequencer, step sequencer, MIDI step sequencer, XL, final, last one. What else? We've got a coupon code for you today. I've got a recap of the product pick of the week. I have a CircuitPython Parsec. I've got a little tooltip related to my my errors with my soldering iron last week. It's not broken at all. What's that sensor error about? I will show you. Perhaps it will help someone out there using that kind of soldering iron understand what's what. It's simple little fix. Embarrassing, but exciting to be able to use that iron again and not just cook things with a heat gun. Cleaned up the workbench a little bit too. That was half my problem. Things had gotten out of control. We've got a bit of a sort of tool tip, Rhino, CAD, Grasshopper, 3D printing, slicing thing that I'm going to show you. We'll spend a little time on that. Over in the chats, we've got people in our YouTube chat. Hello to Dave Odessa, Quinman16, Johnny Bergdahl, Philip Erschler. Good afternoon to you. Thanks for stopping by. And then this is the other chat. If you're wondering where the chat is, if you're over on Twitch or Facebook or something and the chat seems empty, that's because we're using this right here. That's our Discord. So you can go there just by heading to adafru.it/Discord, and then you will look for this live broadcast chat channel in particular during the show. That's where people are hanging out. What do we got? We've got Andy Calloway. Who do we have? We've got David WA90NY. Says greetings from Washington. Hello. Thin Man. Hey. Hope you're having a great day too. I am. Hey, squid.jpg. Hello, hello. Hey, C. Grover. Johnny Bergdahl there. Andy Calloway. Starman, who has... Whoa! That's quite a GIF. I love that. Very nice GIF. Andy laughs. Yes, user error. That was right. It looked like maybe that soldering iron was having problems. I tried to chase down one course of thinking, which was under power, but it wasn't that. Hello, Ralph McCoy, who just joined us in the YouTube chat. So let's get on with it. I think that's what I've got going on for the show. So the first thing is a coupon code for you. If you want to go to the Adafruit shop and buy some cool stuff to build your next project, this coupon code will save you 10% in the Adafruit store. Saddle Stitch, SADDLE-Stitch, STITCH, Saddle Stitch is going to get you 10% off in the store today, good until midnight tonight, East Coast time in the United States. And you can head over here to this place. This is Adafruit.com. Have you heard of it? If you go there, you can look for some neat new stuff like these micro SD card and full-size SD card holder. I might get one of these. I have an older micro holder, but I always need one adapter. I always need a slot for a full-size one, and maybe one of my camera cards can go in there. So I may pick one of these up. If you want to pick one of these up and get 10% off on the total of the whole thing, not just one item, everything you throw in your cart, then that's the coupon code for you. Saddle Stitch. More new stuff right here. You can see we've got a HSTX Pi cowbell for sending out HDMI display from a Pico or RP2040 or RP2350. We have this new Pi Stemma QD breakout for your Raspberry Pi incompatibles. Just gives you a nice convenient way to plug in Stemma QT/Quick cables to a Raspberry Pi. New book, Skill Seeker, Maker Edition by Steph Piper. Go check these things out. These are just some of the new things, and you'll get 10% off the whole order with that coupon code right there. That's good for physical things that we can ship to you. It's not going to work for gift certificates, subscriptions, software, but physical things that we can put in the post for you. You'll get the discount with Saddle Stitch. So do that. That's what I recommend. Hello, VP Tech Ops, just joined us in the chat, waved. If you wonder what I'm doing on Tuesdays and you haven't figured it out yet, here's a hint. It's the product pick of the week on Tuesdays. And on that show, I give you a big 50% off discount. We Adafruit, give you a huge discount on the item just during the show. You don't need a coupon for that one. And I give you a bit of a demo. Here's a 1-minute recap of this week's product pick. Check it out. The I2C to 8 channel solenoid driver. This can be used with Stemma QT, so you've got easy hookup. It can be solderless, because we can provide power to these little middle screw terminals, and then all of the solenoids that you can drive have their own screw terminals. 4 solenoids here, and then the others are sort of scattered around a little bit. Not a typewriter project. I love this project. I made a little mini version of this that I can demo. USB cable running to the computer. The Feather with USB host, RP2040. Then my keyboard is plugged into that. Data and power is going to the solenoid driver board. I have this little baby solenoid here. With every stroke that I type, we get the little solenoid driving. It is the I2C 8-channel solenoid driver board with Stemma QT. Yep, that's what it is. I'm just plugging something in, so I was a little slow on the draw there. Let me plug in the Feather board that I have sitting right here for our next section. And whoa, hey, stop that. I'm gonna ruin all my camera work for the downshooter for this, but it's worth it, right? Here we go. Let's get ready for this CircuitPython Parsec. Oh, haha, I hadn't turned the mic back on from before. Thanks, Andy Calloway just said, microphone. It's okay, I was just vamping as I plugged in something. So, let's get my code window up here and open the code.py off of the CircuitPython drive. That's it right there. Let me open up a Disco tool. -N Feather. Okay. Let's check this out. So here we go. That'll show it. For the CircuitPython Parsec today, I wanted to show you how you can format strings using the replace command. So this is great when you have a bit of text coming in from something like a sensor or a wireless message, and you just want to rejigger it a little bit, reformat it by replacing some text. You'll often end up with commas instead of dots or underscores instead of spaces. So here's a simple example. I'm just creating a message variable here, string called status underscore OK, all caps, sort of thing you might get from a GPS module, let's say. The print here just shows us how that would look normally. Oh, I shouldn't say replaced. That's the original. There we go. Original status OK. Now, the next thing I'm doing is I'm creating a new variable called the display message. It's a more human readable version. And I'm taking the original variable message, string variable, and just throwing in this dot replace, and then in parentheses, the thing I want to replace, in this case an underscore, with the thing I want to replace it, in this case a space. Then I'm printing that. Replaced is the display message, which is this status OK. And now we can make this a little bit friendlier by adding on to that another command, which is going to be dot lowercase, and that does exactly like you think. It takes the original message, and I'm going ahead and still doing the replace, but now I'm tacking on this additional thing of dot lower. So you can kind of stack up these string formatting things. And in this case, I then say print replaced with lowercase message, and that gives us this final one. Replaced is status space OK, all lower caps, much friendlier. The computer doesn't need to yell at us. And that is how you can clean up your text using dot replace and dot lowercase on your string messages. And that is your CircuitPython Parsec. All right, I got my microphone running this time. Thank you. Sorry about that before. Did I have a typo in there? Someone just wrote, yeah, underscore. I think just in my comment, underscore. How about underscore? Let me fix that here. This will, for anyone who's being triggered by that typo. Whew. Okay, replace the underscore, not the underscore. What's an underscore? Thanks, James Williams. All right. So now, next up, let's dive into, how about, yeah, let's jump into this gizmo right here that you can see. I'm gonna raise that camera up a little bit, and I'll fix my, I really need a new, this camera arm is screwy. Oh, Andy Calloway said their cordless headphones shut down. Did I not mute myself earlier? Who knows? I'll believe anything. All right, so let me put my little, ooh, look, there's me, my little funny version of that. And talk about this right here. So this is, you should be able to hear that when it plays. Good, okay, I'm mixing this in directly, so we won't have to use the mic. I will also have some little monitor speakers here for me. So this is the Knobby Sequencer XL Final. Last week we were pretty close with this, but I had made a soldering error, so I couldn't line up all 8, or what is it, 6? 1, 2, 3, yeah, all 6 of these 8-pixel PCBs, NeoPixel PCBs. So I fixed that and put this all back together with all standoffs, all screws, all ready to go. I also added some rubber bumper feet under there. You can see that right there, so it doesn't slide around. I'm going to put another set in the middle just because it can bow down a little bit with the pressure, not much. But so I've got 4 bars of 4 notes each that I can play of a MIDI sequence, so 16 notes total. And what you'll notice right now is the lights are a bit colorful. I'm going to adjust my exposure a little bit darker so you can see those colors a bit better. And let me just double check the focus on that. Nice and clean, there we go. So you'll notice that, first of all, the sequence isn't playing right now. We're not hearing anything. And we got a lot of interesting lighting things going on. So These in front of each knob are still indicating a note that's playing or a note that's muted and where the track head is when we're in playback mode. But I have paused it. Also, I'm in settings mode, and that's why we have a lot of colors on here. So first of all, I'm going to get out of settings mode. There we go. I'll explain what just happened there. So this is the mode that we were used to. I'm going to check my levels on these headphones. So yeah, you can hear me. I'm going to turn down that. Okay, so that should just be coming through the headphones. And why am I hearing that anyway? Oh, am I not hearing the mix? Not sure. Okay, you tell me. Yeah, I'm not sure if my monitoring is right there. You tell me, can you hear my audio and the music playing, and is that mix reasonable? And I will see if I can understand why that's mixed in there so loud. Check, check. Check, check. I don't think I'm monitoring the right thing on that. Okay, yeah, sounds good. Someone said both yes. Thank you, Mastering. Thank you, John Nodge. So, good. So what's going on here? This, not a lot has changed as far as the core thing. This is playing 16 MIDI notes based on muting. If I press a button, I can mute a note. So if you watch this fourth note right here, I'll hold that down, and now we're not going to play a note there anymore. And I can change the note that's playing just by, turn my monitor back on, adjusting a knob. So, for example, bum, 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 right here, I'm going to make this note higher. Next time it comes around, this will be higher. Make it even higher. Next pass through. There we go. So that's the basic idea behind it. This is USB MIDI, so I'm just using a host device. Could be a computer. In my case, it's my little 1010 black box sample sequencer station. However, I've implemented, based on our discussion last week and some ideas, I think Mouse had suggested this and a couple other people had similar suggestions at the same time, which is double-click a button to get into a settings mode. Now, one thing is happening in settings mode. For it to be responsive, I'm sacrificing some timing accuracy. So you'll hear it's either lagging or kind of swinging a bit. First knob here, when I rotate it in settings mode, just pauses everything, which is kind of nice to just be able to pause playback. You'll notice I have some color coding here that's more just to remember which of these do certain things. You'll notice some of them are looking pretty similar. These are the scale knobs. So starting here with this red knob, this gives me the ability to pick different Western scales. This gives me different, I think those are, might be ragas, and so on and so forth. So based on that scales.py file I have some different scales we can use. And I'll demonstrate these while it's playing, but I'll talk about them while it's not playing a bit. So on, off, tempo, we can increase or decrease the tempo with this second knob here. We can transpose by semitones with this one, so we can just move the thing from like C as its root to C sharp just by turning one notch. And I think that's it. Tempo, octaves, semitones, and then we get into different Western scales, and so on and so on and so on. All these picked from different scales. And these last three knobs do something a little bit different. I've got the bass velocity. MIDI notes have a velocity, so the thing on the other end is going to play it essentially louder or quieter depending on how hard you press a key on a velocity sensitive keyboard, but that's just a value from 0 to 127. So I can adjust kind of my baseline of that. I can also adjust some randomization of that. So with this second to last knob, I can say I want the velocity to vary either a little or a lot from note to note, so it just sounds a little more human. And then my final one, which is kind of my favorite on here, is randomize everything. So this will, within the chosen key and the chosen octave, randomize all of the note values inside of the scale and the mute values. So let's start it playing again, then I'll play around with these. So what I'm going to do is adjust the tempo. Let's go a lot faster. Now if I go back out of settings, you can hear it's actually keeping a pace. When we're in settings mode, because I'm polling all of the knobs all the time, it slows things down. So don't believe the timing in settings mode. Okay, back into settings mode, change the bass octave, I'm going to lower it. I'm going to raise it. Now again, if I get out of settings mode, go back into settings mode, timing's a little funny. I'm going to lower the speed a little. Okay. Next is semitone. I'm just going to up the key. So we just raised the whole key. Again. Transpose. Come back down. Come back down one more. And now we start changing the keys. Sorry, the scales. And that's just which notes can play within the scale. Okay. I'm going to go to, actually just going to reset it. I don't have a reset for this, so I'm just going to unplug it. When it starts up, we'll have every note playing, and we're just going to have a chromatic or a scale repeating twice inside of the chosen key. This makes it easier to hear the different keys. You can hear the swing that happens when I go to settings mode. So now I'm going to adjust from, I think this is a pentatonic major to a pentatonic minor. And actually I can, yeah, let's try that. So this should go minor. I think a Dorian, Lydian, and so on. So a bunch of different keys. And now we can go into non-Western ones. I'm not hearing any difference in those, so maybe something's up. I'll look back at that. Let me do the velocity. So you can just makes it quieter, louder as I go from, I think, a bass line of like 100, just going down and then up to about 127. And here's if I try to randomize that some. You hear some accents almost on some notes. And now the funnest one is randomize. Okay, so that gives me a kind of starting point, which is fun. And now I can bring a note back in, adjust that note, go back into settings, make lower that to a bass. I'm not sure how audible that is to you because it gets a little quieter. Let's go back up. Back out. And then you can just go and randomize it again. And if you don't remember this from last time, one of the things that's going on here, I'm going to pause this, is I'm actually, because we're asking for the button presses of these knobs and the rotations just over I²C, which is a bit slow compared to ticking along the tempo of this. I'm only checking each set of 4 because these are four separate seesaw boards. I'm only checking them after the last note of the preceding board. So I don't check any of these until this note plays, and I don't check any of these until this note plays. I don't check any of these until this note plays. I don't check any of these until this note plays. So it just reduces the amount of bulk messages that we're getting in, which can slow things down. And that is it. Yeah, so I've got the full assembly of this. I've designed it pretty simply so that it can be laser cut just from a base and a faceplate and a insert for diffusion. These can, as I think I mentioned last time, my beloved Epilogue Zing 16 laser cutter just suffered a tube death, which happens. It's been like 7 years since I replaced it, and that typically they have about a 5-year life on a tube. So at the moment, I did not laser cut any of this. I just 3D printed it, but it 3D prints just fine in the same. I may get ambitious and do a base that has walls on it, since you can do that in 3D printing a lot easier. And I can up the exposure on this so you can see it a little bit better. So that's, yeah, it's big and open. If you rack mounted something like this, then you wouldn't care, but you may want to put something around the edges there. And that can also be designed for laser cut with notches or layers, but I'm just going to keep it simple for the guide. Let's see. I'm going to turn that down there. I still don't know why I couldn't monitor it, but hopefully you can still hear me. John Nodge said, hey, yeah, double tap seems to work a treat. It's interesting, I think. I'm actually unsure why it is only taking the double tap. I think I'm polling this one while I'm in it in settings mode. I'm checking that sort of with the usual, yeah, so it's harder to get out of it than into it. There we go. You'll notice it's easy to get back into settings mode. And I'm not using interrupts. That could potentially be a way to improve that, getting out of settings mode. There, back up. Pause that. But the code will be there. I've actually put that up already on the GitHub. You can go to Learn Guide repo and check it out. In fact, let me just go there now to show you where it is. Oh, hey, floating head. If we go to GitHub and look at the Learn repo, which is here, Adafruit Learning System Guides. This is called Knobby, so look for the letter K or search for it. I'm going to search for it. Knobby sequencer. Here I've got code.py and then the scales.py. So here's my base scales that I was going through: pentatonic, major, minor, major Dorian, Phrygian, Lydian, Mixolydian minor, Locrian, harmonic minor, melodic minor, blues, chromatic. And then I've got these Middle Eastern scales, Indonesian gamelan, Japanese scales, Indian ragas, Chinese scale, there's just one right now, African influence scale, Eastern European scale, and a Celtic scale. So you can adjust those as you want. Each of these is assigned to a knob, and I think you could ditch some of the velocity stuff or the randomize button if you want to pick up 3 more, or change those to suit your needs. But you know, you could add like a little OLED to something like this if you wanted to see that information. But a lot of this for me is just about playing it by ear and being able to adjust things. If you go into that chromatic scale, you can just pick any note you want. All right, so that's where the Knobby Sequencer XL Final. I will unplug it and then go write the rest of the Learn Guide. I documented it yesterday, took all the build photos. And like I said, fixed that one, soldered on that PCB instead of having wires on it. John Nodge asks, how are the scale knobs configured? Does changing one knob selection override the others? That's right, yeah. So that big chunk of 7 knobs or whatever that handle scale. If you touch one, that one's light becomes purple, all the others stay this light blue. So you know that's sort of the range of scales you're using, and then wherever you're dialing it, I'm not changing colors based on dial. If you head on over to the Middle Eastern scales and touch it, now that takes over. So it seemed like a reasonable way to do it with knobs. All right, so now let's, what did I want to show you over there? Oh, the soldering iron. Let's talk about this. Let's go over there and talk about the soldering iron. What happened? Bring up my Discord here so I can stay abreast. So last week, oh, let me adjust one of my monitors up here. I was trying to resolder a little wire that I snapped off on that sequencer. And my soldering iron said sensor error. And this is one of these very modern, fancy USB-C pen-style soldering irons. And I was trying different USB cables because I was worried I was just underpowering the thing. It comes with and uses a power delivery supply. This is the one that came with it, and this is, let's see, it can ask for 9 to 12 volts at 1.5 amps, and I think that's what it asks for is 9. And I knew that supply was working, and this is a nice quality, thick USB-C cable, A to C cable. But it was throwing a sensor error, so I figured something was wrong with it. I went after the show and looked at some troubleshooting info on it, and one of the first things I saw was one of the main manual's very first page talked about assembly. Oh, I forgot. I've never undone this. That's how it came in the package. It's meant to like fold down real small so you can carry it with you. I forgot it uses this little 3.5mm TRS jack, which is wild, as the connection for power and sensing. So for it to check the tip temperature, which is I think the sensor error we were getting, or maybe there's just a, hey, do you have a tip plugged in at all? This was pulled out a tiny bit, and I didn't notice. So when I was trying to use it, and I got, all right, looks good, great, heating. Oh, it's heating now. All right, let me pull it out a little more. Send error. So it was like there. So enough to get me a sensor error. Plug it in the rest of the way. Let's restart it. Good. If I press that first button, it'll start heating. It also has a little tilt sensor in it, accelerometer of some kind. So I think it will cool itself when it's level. So if you set it down on a surface. Some nice just showed this classic safety first. If it smells like chicken, you're holding it wrong. So now we have, yay, we've solder. I think this, oh, it just said low voltage. I think I'm wiggling this thing out too. Yeah, this is not the original cable it came with, and this one is wiggling a little bit, so that's not a good sign. But as far as the problem I was really having, I'll try some different cables. Sensor error is gone. This reads 8.27 volts. I guess that's what it's using. Kind of curious if we throw a meter in the middle. So yeah, it's about 8.3 volts at 2 amps. It's kind of blinking all over the place. I think maybe this little connection is a little wonky right here. But yeah, it's saying it's at 300C. It's asking for about 8.5 volts. And it's, I wonder if it's sort of pulsing to stay at temperature, like a little PWM thing, and that's why you see this flashing. That's my guess, actually. I think if you set this here, eventually, maybe it just times out. I thought it had a tilt sensor that would tell it to turn off. I usually just, I don't have a good holder for it. I just use this more typical iron holder. I set it in there like that. It's a little heavier because of that meter. Set it in there like that, and eventually it just turns off. But I just got to be careful not to touch anything with that. So there you have it. That was the mystery of my soldering iron last week, and I don't have to get a new soldering iron, which I'm happy about, because I don't solder in here at the workbench a ton. I have another studio inside that I use, and a good iron there. But there you go. That's cool enough to touch already. Pull that out, and I guess this is the deal with these. I don't think the tip comes off of this, so I think you have to buy this entire little assembly if you're going to use different tips. But I just have kind of a nice chisel tip on there, wide chisel tip. All right. Yay. And now, just to share that image. Yikes! That's if you don't know, that's like a stock photo, some stock photo. There's been a few of those over the years of people just models and actors being told to hold a thing, and why would they know where to hold it? It's not their fault. Okay, so now let's talk about, I have a couple of upcoming projects. I'm going to finish this guide, then I've got one that's going to be video overlay Metro RP 2350 related. Thanks, John Nudge, says I get myself a Scooby snack for solving the mystery. Like, zoinks, guys! What was I saying? So, get a drink of water. Remember Casey Kasem? I knew a guy who had a perfect impression of him, so he could say absurd things as if it were the weekly top 40. So, the project after that video thing with Metro RP 2350 is going to involve some juggling balls and some wireless stuff, I think. And it possibly is going to be ESP Now, which I'm excited about. ESP Now is its own sort of hubless, uses the Wi-Fi chip, but peer-to-peer mesh-like stuff, which will, for what I'm trying to do, I think be a lot better than BLE. However, my initial conception before Lamore said, hey, try ESP Now, I think that's better than what you're going to do. I was going to try to do a thing with BLE, and I was thinking about using one of these LED driver boards that we have, the LED glasses driver boards that we have, because they're actually a pretty stealth, cool board. They've got NRF 52840. They've got battery charging on board. They're smaller than a feather. It has an on-off switch. A lot to like. USB-C for charging. So anyway, something's going inside of these juggling balls, or something like a juggling ball. And I wanted to 3D print some balls to start out with. And the problem I found just taking a sort of simple sphere and printing it is that the top, this was printed as two domes. So I printed a dome. If you try to just print a sphere, you're going to either end up with support or some pretty weird steppy stuff at the top and the bottom. These were printed as domes, but again, the top, I want it to be hollow with a thin shell. These might have been in vase mode. The top is terrible. Yeah, I think these were in vase mode. So it just falls off. You can see there, it's doing that kind of stuff. So printing a sphere like a sphere, actually not my favorite. So I think I had seen this sort of thing years ago. Someone printed some sphere stuff that was based on more of a tennis ball. topology. And so the idea here is, if you look at how a tennis ball is made or a baseball, they have either saddle or dog bone shaped pieces that go over the ball. Obviously they start with a real sphere, but the leather and stitching is kind of a saddle shaped thing. Hence our coupon code. I had saddles on the mind, saddle stitching. Or a less aggressive dog bone shape. In my case, I'm actually going with the tennis ball and a very flat version of it. So it's only got kind of the 2 arcs per panel. And I'll be able to fit inside of there whatever electronics, and I'll put some support and possibly a way to maybe just cover that with silicon, pop it into a playground ball, a balloon, something that'll keep it closed, but easy to open up and recharge, rather than the typical thing you'll see with glowing, rechargeable, or BLE juggling balls and similar things. There's been some MIDI instruments that are like this. So they'll have a port and a power switch there, but I may try to do it simpler than that with this construction, since it's not fully embedded in there. At the same time, I wanted to try it out in different sizes and different thicknesses of walls. So look inside of here. I have another one sitting in there, matryoshka-like. This is a very small one, but super thick innards. And so I decided to build a parametric tennis ball generator. I don't know if there's a better name for this type of topology. So that's what I'm calling it. I remember years ago in Alias Studio and Alias Power Animator, which later got bought by Autodesk, or actually became Maya and then got bought by Autodesk. That was a NURBS modeler that I think had a baseball primitive. So NURBS spheres typically have a pinch at one end or 2 ends. And so to remove that pole for different texturing needs at the time, the concept of a baseball style topology is kind of nice. So what I did was I for some reason thought Rhino had a, let me bring myself back into the corner here. I thought Rhino had a baseball geometry, but I think I actually was trying to talk someone at McNeil into it years ago, like 1998 or so, 97, when the original beta was happening, and they said, what do you need this for? They weren't that convinced, so I don't think it ever happened in Rhino. And if you look it up, there's some tutorials of people making baseballs and tennis balls using original NURBS or sub-D or polysphere, and then cutting away some stitch stuff. But I wanted the real geometry to be these 2 intersecting sections. Oh, I like that idea. John Nudge says, model in a groove for an elastic band or O-ring for closure. That's a great idea. Thank you, John Nudge. I may just do that. I really like the hair bands, or the slightly thicker, but yeah, it's more like a silicon O-ring style thing. That's a great idea. So if you create, let me just make a sphere. You can see the type of geometry NURBS want to be by default, or polygons are going to be a whole different story. But that's sort of the topology of a sphere. So what I decided to do was create this grasshopper network here, which allows me to do some parametric modeling. So I can set the ball size. So in this case, I'm going to say I'm going to have a 68 millimeter diameter ball. And part of this is because I was ordering some regular juggling balls, and they come in like 62, 68, 70, 72, 74, 100. And some of those sizes are actually pretty similar to each other. One's a little more like a baseball, one's a little smaller than a tennis ball, one's more like a lacrosse ball. So I just wanted to 3D print some of these so I knew which ones I wanted. That was the original genesis of me building this parametric builder. But what I do is I create a slider here. I think it's an integer slider, yeah. So millimeters in whole numbers. We'll switch this to 67, how about? And then I divide that diameter by 2 to get a radius, which is what my next node wants, which is this sphere here. So this sphere node is now being created at whatever that radius is. I can adjust this here, and you'll see that change, right? So there's my 67 millimeter diameter, which becomes whatever that is divided by 2 as a radius. And at the same time, I'm creating I'm actually deriving an arc from that sphere. So is that right? No, yeah, I'm just deriving it from that same value. So if we look at this arc right here, this is also based on that, whatever that number is. So let's go back to 67. I get an arc, and then I'm using the points on that to derive a couple of lines, which I'm then joining up. So I create this arc horseshoe, which I'm going to then project onto the sphere from the top. Boom. And so what a projection like that looks like is this. If I go to a shaded view of that, I think you can see, go for the wireframe. So there's my sphere, and I've got this projection on it landing on top of it. See it there. So there's the original thing. When it does that, since it's larger than the bounds of the sphere, we get this curvature, because it's just as if you've done kind of projecting with a film projector, but it can X-ray its way straight through. Once I've created that, I can split my sphere into 2 pieces based on that line. So I'm trimming it into 2 sections. So now I've got kind of the outer shell, kind of like these thin ones here. I've got this outer shell of the sphere, and then I can, let's take this one, I can take this piece here and I can offset it to make the innards. So here's the outer and inner shell, and I have a, essentially how thick do I want this to be. I can adjust this in millimeters, how far to offset that. So that's how thick the wall is going to be. I'm doing a 3 millimeter wall in this case. And then I can use those 2 surfaces and their borders to generate a little lofted connection between them, which is what gives us, let's take this example, that's what gives us this, this flat V that it kind of grooves into between the 2 pieces, and that looks like that. So that's just simply the 2 borders lofted with a straight line. You can make that have curvature to it if you wanted to, but I'm just keeping it as a straight line. So here's here's the loft I'm using. I need to ditch that one. That was a more complicated way. So there I get the lip, I get the inner surface, I get the outer surface, and I can join all 3 of those up into one object. So this is the final geometry here, which is pretty cool. Here's a final touch, which is when I started to print these, I wasn't sure which size I was looking at. I was color coding them at first, but if you see on there, this one says 78. So this is a 78 millimeter ball. I didn't want to have to do that by hand, so I automated all of that, or made it parametric as well. You can see here I've got some blocks about text. So this is a text surface that creates, in this case, 67. It's upside down. I kind of have it move around and go to the right place after it's been built. I can't remember why it's building there. I could change it, but I've got to move it anyway. And so this is the factor that I'm dividing its scale, so it scales along with the ball radius as well. I got some factors there for adjusting its font height and the depth of this piece of geometry I make. I'm rotating it in 3D. I'm moving it some amount derived from the radius. So it's actually at the top of the ball there. And then I can chop it out. So there's the top of the sphere with that carved out of there. and I can render that actually to make it look a little nicer. So now you can see if I go and change the diameter, I hope I haven't been saying radius this whole time, it's the diameter. So if I go up to boop, 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 we can have that little cutout there. And then I'll export that geometry. If I take a look over here in a 3D slicer, this is Bamboo Studio I'm using here, you can see we get a pretty nice type of geometry to print. You don't need support material for this stuff. It's gradual enough. It's a pretty thick ball I was making here. This is one of the smaller ones. This is a 46 millimeter. But you can see I'm putting a moderate fill in there, and that'll print really nicely just like that. I've been printing a little brim on the bed for stability, because otherwise it's just like a single thin line or loop as the first thing, and it can get bumped off of there. It's not going to balance that well. But most of this is, flat on the surface, and this is why I didn't go with the more pronounced dog bone or saddle shape of a baseball. I've noticed a lot of tennis balls are actually completely straight like this as well. Some of them have a little curvature to it. That may also be 2D to 3D topology. If you look at the shape, if you look up how tennis balls are made, the piece of felt that gets cut out has a little dog bone to it, but I think that's when that's wrapped. I think they're steamed and wrapped and glued and pressed. They end up with straight seams, which is what I want here. Question over in the chat, someone asked was what software I was using there, then that was Rhino. Yeah, Rhino 3D with Grasshopper, which is the node-based directed acyclic graph, parametric, build your own flowchart of how things get built thingy. And those things can be packaged up into like a single blob that you can share with people that just have like one slider. All it does is change the diameter. You can package them up as like kind of little plugins that people can use too. So that's what the geometry looks like for a particular size of that. Very friendly to print with. Really happy with how this came out. And now I've got a way to make these parametrically, and then I'm going to add to it whatever mounting I'll do for QT-Py ESP32 S3. I think I'll go with in there, and a little accelerometer and a battery, so I can do all the ESP Now stuff and have these talk to each other. I probably won't do glowing. That's done pretty well out there in the world, I think, with some existing stuff. But having messages, and in this case Wi-Fi instead of Bluetooth, is going to be pretty nice, I think, sent to a computer from the ball based on accelerometer stuff. That's my real goal. You could probably print these in translucent materials and do some LED stuff, and maybe I'll give that a try too. But my first goal is really just the sensor data that'll come off of these. So that's something I got up to that I thought some people might be interested in seeing. That's a little look into 3D design for fabrication. Oh, one other thing I wanted to show, actually, because this point about get out of rendered mode, go to shaded. This point about what that geometry looks like. So here's a baked out, at the end of my process there, I can turn that into actual NURBS geometry and then mesh it into polygons. So this is a little cutaway that you can use to look at the geometry here. If I unwrap this, let me see. Oh, there's when I was trying to see if this would fit, what sizes would fit the BLE module. Let's see, do I have, yeah, so if I unwrap this, let me make a duplicate of this. Oh, hey. Pull this over to the side. Oh, you're not, sorry, I wasn't showing anything at all. Okay, cutaway, all I showed was, here's a cutaway. Rip, so we can inspect the insides of whatever geometry by pulling through it. Yes, sorry, the chat is catching up with me and saying, hey, we can't see it. I've fixed it. Sorry about that. So there's a cutaway of the geometry. I've just duplicated a copy of this, and I'm going to bring it over to the side. Let me make this wider for a moment. I don't need Grasshopper at the moment. So I'm going to explode this back out into some layers. I'm just going to grab that inner shell there because it's simple. It doesn't have all that jazz. So if we take this and do a unwrap on it, I'm going to select that set of seams, and this is essentially, I'm going to flatten it, and this is what's done for the purposes of doing fur stuff, more in like Maya and Blender and entertainment-based stuff, adding fur, adding texture maps to things. You generally want to flatten things into a 2D space. So I'm going to flatten that, and then open up the UV editor. And so here you can see, while the UV editor is lit up, this is what that is. That geometry is in a minimally distorted, flattened out view. So it does have that slight dog bone shape, which is what I suspected is the tennis balls start out with that piece, but then when it gets conformed to a sphere, it looks like this, this straight across line here. That thing is a straight line, not so on a baseball. Baseball is a much more exaggerated saddle. So there's what that looks like. And the reason this sort of thing exists is so that you can adjust your positioning of the 2D or UV space texture coordinates to the actual model. So for something like this, you can scale and rotate this in UV space and see what that looks like in 3D space. That's why that exists, if you're curious. I'll cancel that. That was just to kind of show what that geometry turns into in 2D space. Questions from the chat. Someone actually over in YouTube, Dave Odessa, asked, any plans for some more animatronics in the future? I do. Yeah, thanks for asking. I've got some animatronics plans that Phil Tyrone, PT, Mr. Lady Ada, has been cooking up. So we may be doing some more animatronic stuff. I'm excited. I'm puppeteering animatronics, model making, gizmo-y stuff. So we'll see. Oh yeah, Dave Odessa, the 8-channel solenoid driver could be handy for animatronics projects for sure. I'd be curious about maybe doing some linkage building to translate that little solenoid movement into larger scale movement using like little linkages. There's actually a nice example of that in the Ruiz Brothers solenoid drummer project. They created mallets and strikers that work well on a larger sort of moment arm than the little throw of the solenoid is. Other question, Christopher Netherton asked, what is the discount code? There it is, Saddle Stitch. A saddle stitch, saddle dash stitch, saddle hyphen stitch, SADDLE dash STITCH. That will get you 10% off in the Adafruit shop. So that's your answer right there, Christopher Netherton. Let's see, what else? Mouse says, wait, does that mean an animatronic Lars? Actually, that has come up. Could be. Terrifying. See, Grover said, nice space helmet design. John Hodge sees this as a Pac-Man. That's like Pac-Man going like a Charlie Brown, wah. It's like a wah mouth. Thin Man says, cool mini BB2 robots. Yes. All right. That's it. That's what I wanted to show today. Yes, reminder again, there's your coupon codes ahead of the Adafruit shop. Buy some stuff. That is how we stay in business, is by selling things. We put out tutorials and these live streams and open source hardware and open source software and drivers. And that's what we love to do. And the way we can keep doing it is by selling stuff. So we appreciate you. We appreciate you both for your time and community and being part of these shows and our Discord and our forums and contributing as you all do. Thank you so much. And also for sometimes purchasing some Adafruit stuff so that we can keep this wild train rolling. I don't think I've missed any other questions. Thank you, QuinMan16, who said, I love the CircuitPython Parsec music. Thank you very kindly. I'm thinking about doing a new song for this show, for the main intro theme. So when I get some time and hook up the right set of synths and things, I might try to do a new song. Okay, thank you everyone so much. We've got other shows happening. I believe we've got a let me get this out of the way. We've got a deep dive with Foamy Guy Tim tomorrow. We should have some videos of Desk of Lady Ada type of happenings and events over the weekend. And then on Tuesday, I'll be back with a product pick of the week. Wednesday, 3D Hangouts. Show and Tell should be back. Sorry, we were unable to do it. Some things came up yesterday, so no show and tell last night. And then Ask an Engineer. So I'm going to get out of here and go make some stuff, have some fun, do some things. Plug your soldering iron back in. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.